Hello, good morning, everyone. Prashant, audible? Hello.
Hello. Yes, Sanjeev, I'm here.
Yeah. So, good morning, everyone. Myself, Sanjeev Sharma, from Scanpoint Geomatics Limited. You all are welcome the last day of the workshop based on the role of geospatial technology in renewable crop development and indigenous initiative, jointly organized by Scanpoint Geomatics Limited and School of Civil Engineering, lovely professional universities. So now I would like to request the presenter of the day, Mr. Prashant, the Assistant Vice President of GIS Solution Team, Scanpoint Geomatics Limited. So I would like to request to Mr. Prashant, please start the session. Based on the role of geospatial technology in the smart city solutions and urban planning.
Thank you, Sanjeev.
Yeah.
Is my screen is visible?
Yes, your screen is visible.
Okay, thank you. So good morning, everyone. Welcome all of you for this workshop. From last few days, we are discussing about geospatial segment, and we cover different topics where we explore the role of geospatial technology. So in continuation to this, today I'm going to discuss this geospatial technology and application of this GIS, which is useful in urban planning or a smart city implementation. Very quick info, I'm Prashant and I'm from Scanpoint Geomatics Limited. We developed indigenous platform with ISRO. Lots of detail is already discussed in a previous session. So I just skipped this information. Now, based on this IGiS platform, we are working in a various segment, and this urban planning and smart city implementation is one of the segment where we are providing an end-to-end solution. Just give you an overview. So basically, this smart city mission is an initiative by Central Ministry, Urban Development Department. So they publish the guideline which depict the certain rules and mission statement for this smart city. Now, based on this guideline, the objective of this mission is to provide a sustainable infrastructure which improves the citizen-centric services by the ULB. ULB means urban local body. So it can be a municipal commission, municipal corporation, or a Nagar Nigam, any ULB, right? So overall, based on this mission, they are implementing a various solution. So outcome of this implementation is, it's a effective planning, sustainable infrastructure, improve the citizen-centric services, security, safety, and more focus is on transparency and governance. So this is all about this smart city mission. Now, just today we had discussed on the geospatial technology. So role of the GIS in a smart city. So nowadays GIS is not like a map display or information which is related to a particular location. In a smart city, different technology stacks work together. So GIS is one of the core part, or I can say the backbone of the smart city implementation, because it enables the management and integration of the different geospatial data. It can be your vector data, raster data, tabular data, right? So based on this data, it analyzes the scenario, what is exactly problem, what is the solution in context with the location. So crux matter is GIS technology is there to fill the gap between different applications. So overall, in an integrated manner, they work and provide a solution to manage, compile, and analyze the geospatial information for a planning and management perspective. So basically, GIS is a backbone of any ULB or a smart city implementation. Now, in any government-driven policy or a government-driven mission, They have envisaged benefits and objective. So these are the high level objectives of the implementation of the enterprise GI. First of all, the management of the data. Now nowadays we have a latest technology, so it can host varieties of the data from different sources. So first thing is create a data repository. So GIS platform effectively manage a different departmental data, legacy data, tabular data, vector data in a centralized manner. Then digital backbone, once we have a GIS data repository based on the enterprise level functionality, we can provide a different facilities like various department application. Then we can extend the different like GIS services to existing applications. Say for example, a map-based interface with ERP application, integration with the SCADA. Then different types of project management tools are available with the authority in ULB. So GIS play a role in this project management. Then integration with the various smart city application. Like one application is integrated command and control center software. So basically, GIS provided digital backbone for entire smart city initiative. Then it is not an information; it is act as a decision support system. So it provides a various analytical tools to make decision to support their day-to-day operation. Revenue generation. So once we implement the GIS, we can integrate the different types of taxation. Say for example, a property tax or a water tax with a GIS. So this can be helpful to analyze the overall city scenario on a GIS base. Project monitoring, like authority are engaged in various capital project monitoring. So GIS can help to effectively manage their day-to-day field activity on a GIS platform. Utility management. Utility means solid waste management network, then water supply utility, sewerage, storm, road and infrastructure. So these all are utilities where GIS is play a major role to manage this utility. Then maintenance, authority can use a GIS in a field operation, maintenance purpose, asset maintenance purpose, and e-governance and IIIC integration. So these are the objectives, and their authority can take a leverage by implementing the enterprise GIS. Now, as far as as I discussed, based on our IGS platform, we have a different framework available with us. So in a urban information system, these are the major four components. One, we have to create a comprehensive base map. Then we have to deploy a different application module specific to this urban information. Then citizen service application like a web GIS portal or different types of services which improves the citizen centric services, and GIS integration with other application. So these are the four major components which is required to implement an enterprise GIS for urban planning, or I can say for a smart city implementation. Now base map. So basically our software is capable to create a base map as per the requirement. So creating a base map, source of the data can be any. We can create a base map through a satellite image. We can extract the information through aircraft, then through various survey like ETS, GPS, DGPS survey using CAD drawings or available GIS data, tabular data, terrain data, lots of sources are available. So based on this source, we have to create a base map. Now, while creating a base map, there are certain standards are available, as you know. Say, for example, NUIS, National Urban Information System is there. Then recently, we have group guidelines. So these are the standard, and based on this standard, we have to first create a data model. So data model is, I can say, it's a structure how we represent the data in a GIS. Like it can be represented through point, line, or a polygon as per the requirements. Say, for example, major landmark can be represented through point, road network or water supply network can be represented through line, plot, and various administrative boundaries represented in polygon. Then what are the required attribute information for that? Then what are the required symbology? So these all things are covered in a data model. So based on the data model, we have to create an entire base map for the city. This is the typical example of the base map. You can see the view of the satellite image, aerial image. Now feature extracted on using this image, water supply network, road network is there. building footprint is there, then some attribute information, we can attach the attribute information. So this is again as a part of the base map creation, and this is as per the data model. And once we have a base map, we can host this base map, we can publish this data on a centralized server, and based on the data, we have a certain application model. So finally, we have a comprehensive base map. You can see the different types of categories, like base map includes the various administrative boundaries like zone boundaries, ward boundaries, town planning, then road and transportation network, water supply network, it's a water pipeline, valve, junction, property data, land use data. We have to extract the land use through satellite imagery through classification and chain detection method. Then different types of education facility, health facility, green cover area, infrastructure, utilities. So these are the major group which comprise the different layers in a base map. Some source to create a data, like apart from satellite imagery and processing of the satellite imagery, we have to capture some secondary information through field survey. For this processing of the satellite imagery, we have to capture a GCP point from a field through DGPS survey. Then over the ground features are captured through this total station survey, like poles, road, manhole, traffic, junction, street light. In some case, like authority want to identify the features which are available in the underground. So for this underground utility, we have a ground penetration radar survey is there to get the feature. So these are the different types of sources to capture the data, and that we need to integrate with the base map. Apart from this, some property geotagging survey is there to identify the actual property level information, owner of the information. Further, we can link this data with the taxation system to generate an application. For this purpose, we have to use a mobile app to capture this data. So authority can easily identify the type of the property. So it can be a residential or a commercial or industrial, education. It can be depends on the category of the property as per the authority requirement. So these are the various sources where a department can capture the data. They can create a base map and create a centralized database. Now a software part. In any urban enterprise level implementation in urban or a smart city, these are the standard software required. We need a desktop application for overall data management, creation and processing for a vector and raster. Then we require an enterprise level application to publish the data, to enable the various services, to create a different type of portals and application. Then we required a mobile application to support a field level activities and CAD application. So basically lots of data, engineering drawing, planning data, town planning data, different types of building permission related data are available in a CAD format. So we required a CAD and bridging CAD to GIS. So these are the software stacks which is required. Now, based on this different software stack, we have an end-to-end solution, and based on this solution, we are providing a customized solution for different urban authorities. So it's a IGiS enterprise suite. It's based on a service-oriented architecture. It covers desktop, web, and mobile, and it is as per the OGC standard. So basically, OGC defines certain protocols and certain guidelines, like how to share the data, how to download the data, how to update the data, how you can share your satellite imagery, how we can catalog the information from server. So these all standards are defined in terms of WMS, WFS, WCS. Then we have a ready-made framework to create a web-based application. And further, this framework can be extended through APIs, REST APIs and OGC services. So this is all about the backbone of our IGIS technology. Now in any ULB, GIS is basically, we can say it's a fusion of GIS and MIS. So it's a GIS based management system for urban local body. Because on top of the standard GIS technology, we have to configure and customize different functionalities which is required to perform day-to-day operation of various departments. So generally, it's I can say it's a fusion of a special data and different types of attribute data available with the department, and based on the certain customizations, certain functionality, it produces a result on a maps in terms of reports and a charts. These are the standard scope which is required to implement enterprise level GIS for any urban or a smart city. Like we have to create a base map. Either we can create a base map or we can integrate the data which is available with the authority. Then they required a GIS and image processing desktop software, then GIS and image processing enterprise level software and a mobile application. On top of that, a customized web-based GIS application as per the requirement, geo-enabled mobile application. And suppose if you are working with a smart city, then we have to exchange the information between the different software stack. Like we have to share a GIS information with other application, as well as we have to fetch the data from other application into GIS. In this scenario, we have to integrate with other system. And after all, like once you deploy the system, then proper hand holding and training is required to make this operationalized. Now, in any urban information system, you can see these are the standard modules which are required. Application which is related to a town planning application, building permission application, customized application for a water supply, sewage services, storm water management, property tax, slum MIS, vehicle tracking, health. These are the few applications which is required to build on a standard GIS. So we have our standard framework, and based on this framework, we are working with various smart cities and ULB application. So we will discuss briefly every module. So one main application module is for a town planning module. So basically city administration department, or I can say town planner or a team of a town planner, first of all, they want a data. They want to create a data of a master plan of a particular city. So using a GIS, they can create a master plan. Even they can create a development plan to identify the growth of the city using some legacy database available with them. Then image processing, like they can classify the image, they can perform a chain detection and identify the different land use. So based on this, they can create a development plan further through some, town planning rule. They have to create a town planning sheet. They have to create a final plot data, original plot data. So these are the various data which is required for a town planning department. So first, we have to consolidate this data. We have to process this data. We have to create a different layers, apply symbology, attach the attributes, and create a data bank for them. Apart from this, like the town planning department are engaged in various land acquisition process. So the workflow to acquire a land is available in this module. Like they can identify the availability of the land, owner of the land, what is the scenario, what is the progress of the land acquisition, what is the surrounding context, nearby road or any environment related surrounding context, nearby water body. There are lots of things which are required for a decision making to acquire the land. So these functionalities can be configured on a GIS to make easy for them. Then there are different types of reservations like plot reservation available with the authority, where they can build a health center or education facility. So these are the data which requires for a town planning department. So using this data and a different set of functionality, they can perform as per the requirement. They can take a custom printout. They can generate a various MIS report. You can see in this screen. So based on certain criteria, they can identify what are the available reserved plot having certain area or having some administrative issue or any possession related information. So fusion of this attribute level information and a special level information, they can query and analyze the data. In screen, this is a land use pattern of the city. Building permission model. In every authority, or I can say in every municipal corporation, one department is there who provides the building permission. Like basically they manage entire construction activities, building permission, building usage certificate. So they required first of all, they required overall town planning data. Based on this town planning data, they can incorporate the building permission maps. So source of this map is available in a CAD format, because this maps either created by an architect or some civil engineers. So they have to integrate those CAD data on a GIS. Further, our system can integrate the MIS information which is available to that particular building. So based on this information, they can issue the building permission certificate, they can issue the building usage certificate, they can analyze the data, like what are the buildings available for a BUC, what are the buildings available for a permission, pending building permission. Based on this information, they also link the project level detail also, like who are the applicant, who are the developers, who are the architect is there, information of the parking, floor wise information. So this kind of data management and query is possible using this building permission module. So over here, one thing is there. So using this centralized enterprise level GIS, they can reduce the cross department interfaces. Say for example, I want to integrate my building permission plan on a town planning scheme. So I have to, like, every time I cannot go with the town planning department and get the data. Once I have a centralized server, I can directly access the town planning data through browser based interface, and I can plot my building permission information on that particular data. So it's a, it's a certain level of automation to reduce the cross department dependency. Property tax, so basically it's a revenue generation department. So based on the satellite data processing, we extract the building footprint through some secondary or ancillary data source. So like our system can integrate the different property level information and taxation information through APIs or web services or a standard integration approach. Now, based on this data, department can perform various query on a GIS to identify a certain amount of tax or identify a taxpayer. It can be any like type of property. Apart from this, like GIS provides special query and special analysis. So based on the certain scenario, say for example, I want to identify a affected property for my road widening process. So I can easily identify such property on through GIS using my road network data and adjoining property through special query and buffer analysis. Now these are the different types of scenario. We have a real-time information of property tax. So using this information, we can generate a heat map analysis to thematic representation on a map. So this kind of facilities available in a property tax module. Water supply. So basically this module incorporated the special data and non-special data related to your water supply network. So this is again depends on authority to authorities. In generally in every city they have a water treatment plan, water distribution system is there, water storage is there, pipeline, junction, even flow meter. Apart from this, they have some existing MIS application is available with that for a maintenance purpose, for a grievance purpose. So this application and this GIS act in an integrated manner to generate a desired output. So for example, in a water supply, we can identify the different asset on a map. We can query the different asset based on the technical parameters or attributes available with this particular layer. Say for example, I want to replace some specific types of valve available in a X valve. So I just need to query and identify the location of that particular valve. So I can set my work priority. I can get the inventory using this GIS. Then network analysis is there to identify the route to distribute my water supply to a particular location. I can use GIS to enhance the overall utility network, this facility based on the town planning and building permission. As I said, it's an integrated software. So cross department data is accessible to other department. Now, based on this special and non-special data, department can generate a various asset report as well as. This is very useful information for a department to perform their day-to-day activity. Similarly, like every city, they have a sewerage network, which is which cover us. Sewerage treatment plan is there, manhole. Then tertiary treatment plan is there, maintenance of this network, inventory of this network. So department can perform various query using this data and attributes available with this layer. They can perform a network analysis and special query. Buffer analysis is very useful for example, in a field operation using a mobile app, we can identify the affected pipeline, or I can identify a nearby network. It can be your water supply network or a road network. So I can set my work priority in a field as well as. Now, based on this data, department can create a various asset report and integrate with this GIS with other MIS application. In many cases, authority have a separate network for this stormwater management. So we can host this stormwater data in a GIS to generate different queries and maps and special queries. Nowadays, like in any network, like in a water supply network or a sewerage network or a storm network, we have a different type of sensors available with us or IoT device available with us. So we can integrate a real-time information with map to identify the different alerts and generate a notification on a GIS. So this kind of integration is there and is required in a smart city project. So this type of facility is possible on a GIS. So we can easily identify the problems on a field with a real-time information. We can pass on this data to a grievance application so they can plan their maintenance accordingly on the priority base. Road and transportation module. So basically it includes road network, road central line, divider, footpath, traffic island, street light, bridge, culvert, any details. We can assign a symbology, we can create a data model and generate this road network. Now, once we have a road network, this same data we can extend to the ATCS, Adaptive Traffic Control System, or Intelligent Traffic Management System. So they can perform a network analysis. They can, visualize the real-time traffic data by integrating the IoT device or sensor data on a GIS to analyze the scenario. So GIS is very useful to manage their day-to-day road and transportation activities of this corporation. You can see a map, like a representation of different bridges, types of bridges in a different color symbol. Streetlight management. So this is one of the very important module because streetlight is a part of public services. Like every corporation have to provide a basic facility of this streetlight. So they can they can integrate this data on a GIS. So they can overall manage their distribution network of this streetlight based on the length of the road, based on the capacity of the feeder pillar. They can plan the additional requirement of the street light. Apart from this, we can link the grievance system because it's very much required for authority to sort out the different field level problem as soon as possible. So we can link the grievance level information with the GIS. So GIS can identify the incident occurred on a particular location. Based on the different type of incidents and grievance, we can generate a heat map analysis. Based on the historical data, authority can take a decision these are the frequent type of problems occurred due to some certain reason. So they can identify the root cause, replacement of the street light or a maintenance of the street light. So this is again as per the requirement of the department. They can use this GIS method. Solid waste management. Nowadays this Swachh Bharat mission, Swachh Bharat Abhiyan, Green City, Clean City, there are so many initiatives. So to support this initiative, GIS is very useful. Using this GIS, they can plan to identify the different location, waste collection location. They can identify the various places where they can establish the treatment plan. Once they have a data, we can integrate the vehicle, movement of the vehicle, which are part of this waste collection on a GIS. Now, once we have a GIS data, we have a movement of the vehicle. Further, we can optimize the route. for a better resource utilization. So using a network analysis, to cover a maximum this waste collection location, to transfer this waste collection to a treatment plan, how many trucks are required, like which is my optimized route. So based on the certain criteria, we can optimize this route, and this is very useful to any corporations for a better resource utilization. So this kind of facilities is available in a solid waste management module, and further it able to generate various MIS report charts based on the real-time information. You can see on a screen, like using this map-based interface, they can identify a particular vehicle from map, its location, its speed, status, last updated details, then information of a various beam, location of the beam. Suppose if we implement some sensor-based beam, so we can highlight the status on a map, like the status of the beam in a green color, it's a collected, or a red color, vehicle is not on that particular location, and waste is available in that particular beam. So based on the different criteria, we can configure the GIS, and that is very useful to the department to support their day-to-day operation of this waste management. Slum redevelopment plan, like every city, they are working towards the slum-free city. So to make slum-free city, first of every department or every authority first required a data, like what are the how many slum areas are there in my city, what is the household level information, what is my socio-economic data. So this data available in a different format and different sets. So this GIS help to consolidate this data on a map-based interface. We have a vector data, we have a socio-economic details available in a tabular data. We can link this information with GIS. Apart from this, every city administration have a land bank data available with them. So using this data, they can identify a new location where they can plan and slum-free city. And based on this information, various project report they can generate on a GIS. So for a slum redevelopment, GIS is very useful. Apart from this various services, every authority provide access of this GIS-based interface to their different citizen. This is again a part of a configuration part, like citizen can navigate the different data using map navigation tool, display tool. They can search various services available nearby to their area or nearby to their location, because this application can be accessible through mobile also. They can generate a various report, they can take a map print, they can search. So this kind of facilities is possible to configure, and it is possible to accessible to a citizen. Now, as I said, one major part, like implementation of a GIS and customization of the different application module, which is as per the department requirement, which includes data, application, and various attributes. Apart from this, we have to exchange the GIS information with other application. So typically, these are the list of the application. Integrated command and control center application is there, traffic management system is there, solid waste management, mobile application, ERP, environmental sensor application. So in this case, like we have to exchange GIS information to third-party application. We have to fetch the data from third-party application to GIS application to make this entire smart city stack work in an integrated manner. To achieve this integration, our software is capable to deploy various approaches. One is GIS interface through standard OGC services. There is a very standard mechanism to exchange a map through a WMS or a WMTS services, which can be accessible to third-party application. Now, in many cases, some other application is not able to consume OGC services. In that case, we provide a map control. I can say it's a map viewer, so they can integrate map viewer in their application to enhance the functionality. And third approach, we have to we need to capture some attribute level information from ERP or e-governance application. Say for example, the present text scenario of a particular property, or I can say a present building planning permission for a particular building, then reservation detail for a particular plot, acquisition information for a particular information. So these are the different transactional information which is available in any ERP or e-governance application that we need to access and render the result on a GIS. This diagrammatic representation, like any enterprise GIS server who is OGC compliant can easily provide such kind of facility to integrated command and control center applications. So map can be available and accessible to their application, and they can perform various analysis on a map. Similarly, you can see over here, like any enterprise GIS, like using IGiS, we provide a standard map control in any ERP or e-governance application. So based on their workflow of ERP or e-governance application, they can interact with the map, they can generate a different output based on their workflow. So this is the second level of approach where we have to integrate GIS with any third-party application. And real-time transactional information we have to fetch from MIS database. So we can render the result on a GIS. It shows the taxation information or a building permission information. It can be any, like this is again depends on the requirement of the different use cases of the authority. So our system is capable to integrate the GIS data, is capable to integrate the MIS information through APIs and OGC services. Now, one more major component is a mobile. So overall mobile application is useful to support the field level activities. So field level activities can be any, it can be a task of the some data collection. It can be a task of the maintenance activity, then grievance activity to update the status on a real-time basis. So we can use this mobile application and configure as per the requirement. These are the out of the box and standard features available in a mobile app. Like authority can view the data, they have a layer management to on off the data, they can access the different maps on a field, they can navigate the data based on the location, based on the different map navigation tool. They can capture the data in terms of point, line, polygon, they can attach the attribute. These are the standard functionality. Using GPS, they can exactly get real-time location, some formatting identify tool. Now, how they can enhance this field level operation? So as a part of enterprise suite, like we have a form designer, like suppose if I want to capture a data which is related to my landmark, so I can design my form to capture the landmark information. Second example, if I say I need to geotag my property information, so I can design my form as per the property tax department. So this form designer is available with this enterprise level solution. So dynamically it capture the data on field in an offline as well as in an online manner. You can see over here. We design one form and my surveyor team can work in a field. So I can assign a area of interest for a surveyor. I can capture the geotag information. Further, any background map can be accessible and it can work in an online and offline. So basically it's a operational level functionality. Day to day authority have to update the data. They have to update the status as per the requirement. Further, authority can monitor this data management activity. They can mark the area of interest. They can retrieve the data which is captured by a particular survey team. They can track the route of the surveyor. Now, based on this data, we have various infographics that generated in a GIS. It can be your charts, MIS report, tabular reports. reports in a PDF format. Then special queries tool is there, heat map is there, cluster map analysis is there. So basically this dashboard is required to monitor overall real-time survey activity. You can see the status, like a symbolic representation of the data, like a major landmark is represented in a point data, some residential properties available in a green. Similarly, we can generate a different type of charts, status report, property wise report, property type wise report. So this can be any, like similarly, this tool can be capture the data of a grievance. This tool can be capture the data of maintenance activities which is occurred on a field. So overall, the role of enterprise GIS is to implement a GIS platform, integrate all available data, create a data, further customization of the application module, and workflow for a data creation and updation as per the requirement. Once we have this system, then we have to share this data with other application. It can be your ICCC application, solid waste management application. So similarly, this enterprise level solution work for any smart city or a urban planning. Okay, I'm done with my side. We can discuss if any query.
Hi everyone. If you have any query related to today's topic, you may ask directly to Mr. Prashant.
Hello, sir.
Hello.
Good afternoon, sir. Actually, I was just asking how can we download this IGS software in our PCs also and do all the things like you had just explained?
Yes, sure. You can perform the all activities on IGIS desktop, and it's a 30-day free trial is available. I also shared some contact details and email address where you can request for the IGIS trial. You will get some links where you can download the IGIS trial version.
Okay, sir. Thanks.
Details are mentioned in chat box. Please look into this. Okay, thank you. So now I would like to thanks everyone for joining the sessions, and also as well as the grateful for having School of Civil Engineering, Lovely Professional University as a joint organizer of the event. And big thanks to Dr. Amit Srivastava ji, Dr. Janki ji, Dr. Ganesh ji for your impressive support and coordination to make this program successful. We also have grateful for our guest speakers, Dr. Harramdeep Singh Sidhu ji from PEC Punjab, PEC Chandigarh, and Dr. Amit, Dr. Manmohan Yadav ji from MNIT Allahabad, Dr. Indramani ji from IIT Ropar, Mr. Kishan Kant ji from Scanpoint Geomatics Limited, and Mr. Pashant also from Scanpoint Geomatics Limited. So thanks everyone for joining us for this make event successful. Thank you everyone for your patience and coordination. I think Prashant, we should have to close the session. There's no more queries.
Thank you everyone.
And we have requested also for all participants, please fill your feedback form carefully. On the basis your attendance will be submitted to the university, and also on the basis we will provide you the certifications in the coming days on your mail, on the registered mail form during the registration form. So please fill it carefully. Thank you everyone for your support.